Let's continue with another example. We want to find the equation of the tangent line to x squared plus y squared equals 25 at the point 3, comma, negative 4. For the equation of the tangent line, we can use the point slope formula. The point slope formula says y minus y1 equals m times x minus x1. So to use this formula, we need the slope and a point. We have a point 3, comma, negative 4. So my x1 is 3, y1 is negative 4. Now we need to find the slope. Remember, the slope of the tangent line is the derivative at that point. From the previous example, we found dy over dx equals negative x over y. This is the derivative of y with respect to x. So instead of differentiating again, we can use this result. Now, let's find the slope at the point 3, negative 4. To find the slope, we use the equation dy over dx, and we evaluate it at the point 3, comma, negative 4. We'll replace x with 3 and y with negative 4. So the slope is 3 over 4. Now, we'll replace m with 3 over 4, replace x1 with 3, and replace y1 with negative 4. M is 3 over 4, x1 is 3, y1 is negative 4. So I have y plus 4 equals 3 over 4 times x minus 3. This is the point slope form of the tangent line. If the question asks for the slope-intercept form, then you would solve for y. Otherwise, it's perfectly fine to leave your answer in this form. Now, let's look at another example. Find dy over dx if 4 times x to the 5th plus tangent of y equals y squared plus 5x. Again, notice that y is mixed in the equation, so we'll use implicit differentiation. First, differentiate both sides with respect to x. So I take the derivative of the left side and also the derivative of the right side. Now let's differentiate each term separately. I'll take derivative of 4x to the 5th plus the derivative of tangent y equals the derivative of y squared plus the derivative of 5x. The derivative of 4x to the 5th is 20x to the 4th. To take the derivative of tangent y, we use the chain rule. The outer function is tangent and the inner function is y. The derivative of the outer function is the derivative of tangent, which is secant squared of y, times the derivative of the inner function, which is the derivative of y. To find the derivative of y squared, we need to use the chain rule again. The outer function is something squared, and the inner function is y. So first, we take the derivative of the outer function. So we have 2 times y multiplying by the derivative of the inner function, which is the derivative of y, plus the derivative of 5x is 5. The derivative of y is dy over dx, or you can also use y prime. Again, the derivative of y is dy over dx, or y prime. Remember, we need to find the derivative of y, which is dy over dx, or y prime. So from here, we need to solve for y prime. This term and this term contain y prime. So we need to move them all to one side. So I'm going to go ahead and subtract 2y prime from both sides. And we need to move the term with our y prime to the other side. So we are going to subtract 20x to the fourth from both sides. So I have y prime times secant square y minus 2y prime equals 5 minus 20x to the fourth. From here, I'll factor out y prime. Now I have y prime times secant square y minus 2y equals 5 minus 20x to the fourth. To solve for y prime, I divide both sides by secant square y minus 2y. And I have y prime equals 5 minus 20x to the fourth over secant square y minus 2y. And this is the derivative of y, or dy over dx. And that's how implicit differentiation works, even with more complicated functions like trig functions.